that water might be the more precious of the two. Section 1. Feats of Engineering. Grand Coulee Progresses by R.G. Scarrett. Grand Coulee Dam in the state of Washington is being steadily reared from the depths of the Columbia River Canyon toward its ultimate maximum height of 553 feet. Work on this tremendous undertaking has been divided into two major contracts, one embracing the building of the so-called low dam, rising well above the high water level of the river, the other calling for the completion of the integral but surmounting section, which will carry the dam upward to its prescribed final crest line. The low dam section was finished in January 1938, and work on the remainder of the gigantic concrete barrier was started during the first half of the current year. The low dam was authorized in 1934 because it would give relief to the unemployed and the structure, when finished, would make it possible to generate a large block of marketable electricity when plant for that purpose should be installed. The building of the high dam, now underway, will serve much broader fields because it will make possible generation of a considerably greater amount of power and render practicable irrigation of 1,200,000 acres of rich but now virtually arid lands in the Columbia Basin. Indeed, the fundamental purpose of the Columbia Basin Project, of which the Grand Coulee Dam is the key feature, is the agricultural development of this particular region. Any surplus electricity may be distributed to consumers located within a radius of 300 miles from the dam site. The lands to be benefited by water pumped from the river will provide home sites for some 150,000 persons and will, in addition, support on the project an urban population of 150,000 people. The fruits of the soil will, of course, be distributed throughout a far wider territory and contribute to the sustenance and well-being of a great many more thousands of our citizens. When the Columbia Basin Project was described in these pages early in 1935, some emphasis was laid on the geological happenings that brought about the erosion of the deep, broad, and long Grand Coulee, which, for 25.2 miles, is to be used as a balancing basin to store, for a prompt drawdown, 329,000 acre-feet of water that can be fed by gravity flow whenever needed for irrigation. But nothing was told in our earlier article about what the same stupendous forces did 25,000 years ago in the canyon of the Columbia, where the Grand Coulee Dam is building. The invading ice sheet, which blocked the canyon below the dam site, raised the level of the river about 1,500 feet and detoured the stream westward, where it eroded the Grand Coulee and, incidentally, overlaid the bed of the Columbia with a deposit of glacial drift, or till, that attained a vertical thickness of 500 feet. What happened afterwards, when the river worked ceaselessly to readjust itself and to burrow downward toward its ancient level, brought about conditions in the canyon that have presented major problems to the dam builders. When the Cordilleran ice sheet retreated and the Columbia was free to resume its ancient course, the river proceeded to dig into its new bed of glacial material and to scour restlessly an ever-changing channel until it worked its way to the course traced by it in modern times. At the dam site, in midstream, the bed of the river is now from 40 to 50 feet thick over the underlying and far-reaching basic granite. From the center of the stream, outward and upward throughout the length of the dam, the overburden, of glacial origin, increases in depth to a maximum of 200 feet, but beyond that range the depth is greater. The canyon slopes are blanketed to